This is Ahmed Mahmoud Khalil with you in gene aggregation in Hadoop, prepared by Ahmed Mahmoud Khalil and Ahmed Talat Hatata and Ayman Muhammad Yusri. Why is gene aggregation? Gene aggregation is used in clinical applications to identify transcriptional signatures and patterns of gene expression data. Used also to see how genes are grouped together into sets of genes and how this affects the overall analysis. The input data for gene aggregation are patients' biosets. The bioset is a list of key value pairs where key is the gene ID and the value is a list of associated attributes. How is gene aggregation achieved? Gene aggregation is achieved by using three metrics. First, the reference type, which refers to the type of patient data. The gene filter type, which refers to type of filter applied on the data, and the filter value threshold, upon which the gene filter type will exclude the gene which doesn't satisfy this threshold value. For example, if filter type is up, then only genes value which are greater than this filter value threshold will be considered for further analysis. The input data, gene ID and reference type, and patient ID gene value, and the output should be the gene ID and reference type and the frequency count for this gene. We have two ways to calculate this frequency count depending on the average of the value related to the threshold detected, and the other way, which is individual one by one. We'll begin with the average, which has a mapper and reducer and driver. Here in the mapper, we just emit the key part and the value part. Looking here at the data, just emit this part and this part. The reducer should calculate the average, then check this average with the threshold, then count the patients which passed, how many patients passed this check, and this is for the frequency count. So we first should calculate the average for every patient, then check this average regarding to the threshold value. After this, we count the averages past the check test and get it as the frequency count. So here we first build the patient map, will carry the patient ID and an instance of pair double and integer, which will carry the gene value and count it, increment every time, increase this count with 1, increase this count with 1, and plus the value. So at the end we can get the average for this patient. After this step, we have to calculate the number of patients passed the test. So now we have a patient and its average, so we compare this average with the threshold value and plus the passed test. So here we count the patients which has a very average passed the check test compared to the threshold value. After this step, we have the number of patients passed the check, so we emit the key, which is the gene ID and reference, and the number of patients passed this test. Here, looking to, we here run the code by individual, and this is the final result: the gene ID, this reference, and the count of the past data. Now we will see how to do this in Spark. In Spark, we will use Python prepared by Ayman Yusri and submit it on Spark, and as we see, here will present the individual case. Here first the data, we will load the data. This is the path of the data. We will create an RDD using the context. Here at the first line we get the Spark context, load the text file to a data RDD. After this we will map this RDD. First thing, each line will be divided into two pieces. The first one using the semicolon, the first one will be the gene ID and the reference type, and the second piece will have the patient ID and the gene value. We will here map the first one, the line, to the first piece and the second piece. Second piece will be splitted using the comma to get just the gene value. This gene value will give this gene value to a check filter to check for the action we want to do on regarding the threshold and the threshold needed to filter with. This is the check filter function, the gene value, the filter type, and the threshold. With the if condition, we will emit either 0 if it is lower than it should be discarded, and 1 if it is needed to be calculated. After this transformation, using the map function on the data, we reduce it by key and emit the summation of these ones to get the sum for every key. Let's see emit for this Python file. And this will print for us after the aggregation.